Now, the first, let's suppose the first part of this problem leaves you cold. You have no idea how to derive that. Maybe you set up a couple equations. You might get a few marks. Understand that the second part of this, they just want you to plug numbers into the formula they're giving you. They told you that A is mg over 1/2 m, big M plus m, right? Okay. Well, you can just plug it in, right? You can just plug the stuff in there and get the acceleration, right? So this is just really a Suvat problem. Plug it in first, right? So plug this guy, bucket mass, in for that guy, right? Plug the big M in for the big M, right? And this guy also plugs in here. And arrive at an acceleration. This acceleration is between 5 and 6 meters per second squared. And then Suvat it. Right? It starts from rest, so the initial velocity is 0. This is our displacement, right? The acceleration you got from this, and then find the final find the final velocity. Use what v squared is u squared plus 2as or something like that, right? Okay. Don't give up. You can still get these 2 marks, even though you had no idea how to get that. You still get 2 marks here, right? Okay, and then the rate change of the angular momentum of the cylinder. Dear Lord. Well, in linear land, the rate change of linear momentum is the force, right? So in rotational land, the rate change is just the torque, right? Torque is change in L over change in T, right? Are you going to remember that on the test in May? I just don't think so. There's 2 ways to do this. Okay, way number 1 is to remember that it is the torque, right? That it's the torque, right? And torque is I alpha, right? Alpha is A over R, right? Where this is R, 0.2, right? And I is 1/2 mr squared, right? So just plug it in. There's your big M is 36 and R is 0.2, and happy hunting, right? There's your torque. And then just, keep track of your units, because you got to label it with units, right? Okay, so this is way number 1. Are you going to remember that? I just don't know. Okay, so what I did, I was thinking maybe you would remember that the rate change, you could figure it out in here. Basically, it's going to be just change in L over change in T, right? And L is I omega, right? Okay. And then T, well, what is the T? Well, you can Suvat. We found the final velocity. Also find the time. The time is somewhere between 2 and 3 seconds. 2 and 3. Okay. So find the time. It's like, I don't know, 2.3892 seconds or something like that, right? So find your time. Okay. Then, don't give up, man. It's 3 marks. Okay. And then the change in angular momentum would be the moment of inertia, which you'd find with 1/2 mr squared, right? So here's your M, here's your R, right? And then your omega is, of course, just V over big R, right? Your V is the answer that you got from here, something between 13 and 14 meters per second, right, is the answer to this guy, okay? So find that V, and that's your omega, right? V over R is omega, and then this is this. And then the T you got from here, right? That maybe you'd remember that. I think you'd remember that, right? Okay. And then C says the bucket's filled. So this has nothing to do with all this now. Now they're just giving us a power problem, right? And power is in the data packet. I believe they say force times velocity, right? You can do that, and the force would be mg. Where this is our mass of it now. It's now a different mass. It's no longer the 24. Evidently it's got 21 kilograms of water in it, right? Okay, heavy bucket. Okay, and then your velocity is 2 meters per second, right? So you could plug that in and get the power that way. Another way to find the power, power in the data packet is also work over time. Okay, so if they give you 2 meters per second, that means 2 meters in 1 second, right? So the work would be mg, the force, times the distance would be 2 meters, right? And then your time would be 1 second, right? So you could use work over time. Just remember what that means, okay? Happy hunting. The answer to that is between 800 and 900 watts.